everyone. We're from Honeywell Intelligrated, and we're basically here to share how using some of Databricks' new services helped us improve our business and our customer experience. My name is Quentin. This is my colleague Priyesh. We are data engineers, and we work for Matul, right? So just as kind of a quick overview so you can follow the storyline, Matul is gonna go over the business development impact that our journey with Databricks has had. I will go over some architect and build stuff, and Priyesh will show you some build and optimize stuff as well. So that's the general layout for the talk. And with that, I'll hand it over to Matul.
Thank you, Quentin. So I'm here to talk about the boring stuff. I'll try to keep it as entertaining as possible, but basically, I'm sure all of you have heard of Honeywell. And I'm sure when you first think of the name Honeywell, you probably think of air filters, thermostats, things like that. But we work in the industrial automation division. So our hardware is conveyor. Miles and miles of conveyor for a lot of big box store companies, online retailers, things like that. And our software runs on basically all industrial platforms. So we have hardware and software all over the world. Just for those who don't necessarily know what conveyor is, beyond what you see at the grocery store, this is a conveyor system. You can see they're quite large. Again, 15, 20 miles is not uncommon. Floor hung, floor supported, ceiling hung, the most tight places you can ever get. So it's, simply put, we move boxes. We move things from A to B, and it can be as small as a ketchup or something that's tiny, very light, to machinery, pallets weigh thousands and thousands of pounds. So we move a wide variety of items. Now, when we're moving these items from A to B, our systems generate data. And they can be in the form of carton counts. So the number of times a carton has passed a simple point. It could be scanners that are reading the barcodes that are on the cartons. It could be cycle counts on the motors turning on and off. It could be a wide variety. So thousands and thousands of data points are being generated. And historically, in our industry, we have always overlooked or non-standardized and effectively just ignored this data that's being generated. So that poses common challenges that our customers have seen. And we have customers across a wide platform, many applications, like I mentioned before, depending on what the customers are trying to move. So common challenges we found across those customers, it comes down to simple performance and scalability of actually being able to capture and collect that data. The biggest issue is, I'm sure some of you are probably aware of it prior to your being involved with Databricks. How many times was data collected and tracked on Excel sheets, manually built PowerPoints, things like that. So again, common thing in our industry. Data sharing. They have all these systems that run these conveyors. So our control systems, the maintenance systems, all these different data points are being generated from all these independent systems, but they're not being unified. They're all siloed. So again, common challenges that we're finding, even in the reliability of the actual data itself. Maybe there's corruption when someone's typing in the Excel files, or even transferring large data from different systems to just try to use it. We have a lot of reliability issues that our customers are looking for. So these new solutions from Databricks is what driven our services. And again, I'm going to keep this quick because I know you want to talk to these guys, not me. So our new services that we're trying to drive, and again, this has been with the help of Databricks, has been in two parts. So there's the back end and there's the front end. So from a customer perspective, you'll see the high fidelity analytics. Now at Honeywell, I don't know about you guys, but at Honeywell, we love acronyms. So trying to play into that, we decided to make our own. So we call it HFA for high fidelity analytics, which is our main service. And the back end is our DC squared, which is what these gentlemen are going to talk about today. And that's a lot more interesting aspect. So these services drive solutions, right? It gets rid of all of our problems that our customers are, having. connecting data sources, driving KPIs, optimizing data collection. And then on the service side, which is our HFA, is where we drive our customers' understanding and leveraging of that data. Now, there's strategic KPIs, there's streamlined decisions that can be made, and what this allows our customers to do is leverage their data, make decisions faster, and make better decisions. And that drives to our growth. So this is a very early on program overall. So we're driving with the idea of working with our customers. So working with our early adopters, our pilot systems, we've been working with our customers to extract the information, try to make sure the system is driving what's important to them. This collaboration has been a key insight to our overall growth, our contract offering, our aftermarket services. So it plays into a lot of things that we do at Honeywell. And again, focusing on what our customer wants, that's where the transparency comes in. At the end of the day, everybody wants their data. We're here to collect it and leverage it, but it's our customer's data. So driving delta sharing has been a massive endeavor for us and supports our overall targets going forward. So with that, I'm going to be done with the boring parts. I promise I'll be quick. So Quentin's going to go over the fun stuff for you guys.
All right, thank you, Matul.
Yep.
All right, so what I'm going to do in general is go over our main business pain points and customer pain points. Then I'm going to map them to solutions that kind of alleviate those pain points. And then we'll give you kind of a preview on some of our upcoming innovations, and we'll go from there. So with the business pain points, we had three different types, different categories, right? High level stuff was lack of standardization. The way that our previous platform design was, it wasn't built to be scalable. It was very temperamental and not fun. And then we also wanted to reduce technical debt that goes with the lack of standardization in the temperamental non-scaling legacy platform. Basically what that means is, well, first of all, there's a bunch of data people here. Can I get a hand raise? Anybody who's run into similar issues in your experience? That's a lot. That's like over half the room. So you guys definitely know the pain. And then scalability and performance, I think I went over all this. The one thing I want to mention there is that legacy architecture pushed a lot of calculations to the BI provider software. So in Tableau in this case, dashboards are really slow, not good. We changed that obviously. And then also, like Matul mentioned earlier, self-service data sharing was delta sharing. Allows us to share our customers' data back with them, right? They have all this data in all these systems. They don't have the resources or knowledge to collect it. So that's where we come in, extract it, and make it available back to them, while also providing insights with our SME knowledge. So there's all that. And then kind of mapping them to the solutions. So at high level, migrate and standardize, building on scalable, durable stuff. So basically what that means, a good example of that is switching from like non-Lakehouse to Lakehouse architecture. So the old way was like a 2-hop or 2 data silo typical workflow, right? So we would get something with like a function app or logic app or something, and that would drop it in a storage account. Then we'd use ADF to kind of pick it up, copy and transform it, and put it into SQL databases, right? That's 2 data silos right there, not super efficient, right? But when we re-architected everything and just did the initial load into storage, and then obviously have the ACID transaction compatibility on just the storage itself, we eliminated one silo and reduced the complexity of the pipeline builds, obviously by like 50%, which is really good, right? When you're trying to scale and standardize, 50% reduction is great. It's very helpful. And then the other cool thing is we don't have to babysit the SQL DBs anymore, because even if you do vCores with those, you have to scale them manually, and sometimes you're not able to scale them independently, like compute and storage, right? No separation there. If there is, it's not very good. With the new architecture, we obviously completely decouple storage and compute, and that's been a lifesaver for us, right? Because we can just let everything chill in the cloud storage and then spin up whatever clusters we need to, while also keeping an eye on cost, I will say. And then, like I mentioned earlier, we were able to shift the calculations from the Tableau dashboards back into Databricks very efficiently, a very standardized way, and dashboard performance increased, customers were happy. And then obviously with Delta sharing, that's a simple thing. It's kind of like I think of it as like a cheat code, because instead of us building a pipeline on our side to push into a bucket or something, we just basically create the share and recipient objects in our Unity catalog metastore, and then we just have them pull it, which is really nice, right? Because we don't do anything except for provision the objects. So I think I had a thought on something, but I don't. I'll see if I come to it later. Okay, yeah, there it is. So full disclaimer, first time speaking and doing demos, I overbuilt the security platforms, like the networking stuff on the demos, so they're not like 100% finished, but some of them are. So I'll show you what I have finished. DLT streaming is one of them that is. So I'll just kind of show you what I mean, what I've been talking about. Okay. So what you're looking at right now is a DLT pipeline. It's just one table, but what it's doing is pulling in data from a demo producer. So the data that you're gonna see in the table, it's not live or anything. We wanted to keep it PG for legal, so they didn't have anything to worry about. Basically what we're doing is we have a data producer. It has a broker on it. It pulls, in production in our systems, it would pull what's called OPC UA data from controllers, and it would throw that to an event hub. And then the event hub would be subscribed to by something called a Spark Kafka connector here in Databricks. And then that's how we stream in the data, right? That's a simple version anyway. There are actually many different ways to do that, and depending on the security requirements that you have, you could be required to, for example, make the event hub private only, do a private endpoint, stick an Nginx reverse proxy in front of it, or I've heard of people using VPN gateways and stuff like that. So, but basically, let me show, that's not the notebook, I can tell by the title. Let me open the notebook, just so we can look at it. Quick question while I'm doing this too. How many of you are not using DLT at all in your Databricks environments? Anyone? A couple people, okay. So there's still some people out there who aren't super familiar with this, but it seems like most people are, which I'm personally biased. I think it's great because I'm very new to the field, and it does a lot of stuff for me that I don't have to worry about. But let me go. All right, so basically what you're doing when you're setting up a stream like this, again, this is for those who are not familiar with it yet, which there are some of us in the room. Glad to have you. So basically what we do is we just, in this case with the event hub, we just give it like some parameters. So the namespace, the event hub name itself, the SAS key and the SAS key name. And then we basically do like a little Spark, set up a Spark, a Kafka config, and then we just define a DLT table and put these options in here, tell it to subscribe to the right event hub, do the bootstrapping. And it's really easy. See, like, I don't know how many lines, but it's very few. Half of the ones up here are, what do you call it, comments. So very, very easy to do. This is actually very similar to what we do in production. And we have, I see both the guys who helped us with this in the room. So Chris up front kind of helped us with the Spark Kafka connector. Paul guided us on that path at the beginning. So thanks, guys. Glad to have you here with us. And then we'll just show you, I guess, oh wow, it took it out of the, we'll just expand it here and then kill it anyway. But yeah, this is just basically test data. So it's dummy data, that's why it's not readable. But basically what you're looking at is the producer has a bunch of tags, and it looked like different Chris, another IGS colleague, he just put the same value in there. So, but it's just kind of cool, right? Like in the past, I bet you would have had to spin up so many different systems, so many different tools. It would have been nothing near as easy as this. So this is one of those things where I just showed you how simple it is. Scaling with these types of simplified tools and pipelining helps us become so much more faster, and we're able to respond to customer demand more quickly while also keeping security satisfied, right, with their needs. So I'm gonna click out of that. And next thing is just gonna be showing a federated query from a SQL database. So this is another thing, if we want to go and like explore different data sources, but we don't want to necessarily go through the trouble making a pipeline, then we could just do this, right? It's pretty simple. You just set up a couple objects, a foreign catalog, and in a connection in your workspace, and then from there, you don't even have to use like code. You can just do it through the UI if you want, but obviously it's quicker in code. Yeah, this one, and if those of you that are Kaggle, if this looks like the car telemetry data set, trust your instincts, it is. But yeah, it's just really quick, right? Like I set this up, it took me like 5 minutes to do it, and we do this in production too, so like with different Microsoft SQL servers and stuff that we don't have access to yet, we just wanna explore within the company. So that's another big help for us. And then yeah, after that, the Delta sharing, I was gonna have something on that, but I didn't, that was the one I didn't finish. So I regret I'm not able to show you that one now, but what we'll do is go to incoming innovation. So basically what we're doing is we're gearing up after wrangling all our data to develop a few things. We'll have a domain-specific ML applications, so like preventative maintenance and stuff like that, and as well as like specific Gen AI stuff for like reading contracts and all that. So that's coming soon, and we're really excited for it. So with that, I'm gonna hand it over to Priyesh, and he will walk you through Build and Optimize.
Thank you, Quinton. Good afternoon, everyone. I'm sorry, I just realized it's still good morning. Good morning, everyone. I'm excited to share with you how Databricks has transformed our data by unlocking the full potential of it. So let's talk about development velocity. Firstly, let's talk about before Databricks, we faced a lot of challenges. So our data load times took several hours for a full refresh. We had to do a manual setup for an incremental refresh, which was both complex and time consuming. Another issue that we faced was we had a fixed CPU usage that limited our performance scalability. And we lacked intelligent AI assistant for bug review and issue resolutions. So does this sound familiar to anyone? I see a few nodding heads. After Databricks, what we got was things got dramatically improved. Our data load times are now under 30 minutes, thanks to more efficient processing. Our incremental refreshes are now automatic with Delta Live tables, reducing manual work and errors. Photon acceleration lets us boost performance whenever we require it. And the Databricks AI assistant helps us review bugs and offer insightful suggestions, saving us a ton of time and increasing productivity. Now, let's move on to optimizing data pipelines with Databricks. Here's how we did it. We used materialized views, and that allowed us to store and retrieve pre-computed results, making our queries faster and our dashboards faster. We can run separate tasks in parallel, speeding up the entire pipeline process. Databricks offers development and production modes to ensure smooth transition and consistent performance across different environments. And again, photon acceleration has helped us gain performance boosts whenever required and wherever necessary. Let's take a quick demo to see this in action. Yeah, so this is a demo DLT pipeline that I've created. So it takes data from Azure and reads the data. And what I've created is a materialized view. So here you can see that we had a price of each and we had quantity ordered, but I wanted to get total sales. So in order so that our BI software Tableau does not have to do a lot of loading, I did the calculation on the back end. So that helped us create another field for them, which was much more faster. So as you can see, these two, when we run the pipeline, these two, bronze and gold, like there should be a silver as well, because they all are similar. So that's why we eliminated the silver portion of it from the medallion structure. So as you can see, these two, like bronze and gold, they all are a streaming table, while the MV demo GD calc is a materialized view. It is because we did some calculations, and that is going to help our BI team and load the dashboard faster. Let's move on to, let's discuss integrations, starting with Tableau. The Databricks connector lets us directly connect to the Databricks clusters, simplifying data access for visualization and analysis. We can also use ODBC or JDBC drivers to connect Tableau with Databricks, making data transfer and visualization seamless. These connections improve our dashboard performance, providing a smoother data visualization experience. How about Azure? We use Azure Databricks Access Connector to easily transfer and analyze data between Azure Databricks and Azure SQL Database. Another thing is Azure Data Factory. It helps us set up automated pipelines from moving data from Azure SQL Database to Azure Databricks, creating seamless workflows. And for sharing data with clients, as Quinton mentioned, data sharing enables real-time data sharing, giving instant access to the latest data without any duplication or delays. It provides secure, unified access to data across multiple platforms and environments. Finally, let's discuss alerting. Databricks offers robust alerting features to ensure everything runs smoothly. One thing that we use is job duration warnings. It helps us identify bottlenecks before they become problems. Another thing that we use is we create our own custom SQL alerts for specific monitoring of metrics and triggers based on our own predefined conditions. And we also get instant job notifications on job success or failure. That ensures us that we can respond promptly to any of the issues. And now let's check out the alerting capabilities demo. So here I've created a sample query that tells me that if the table is not updated in the last 2 hours, that means something is wrong, and it will send us an alert with the help of the alert setting. I'm using information schema in it. Information schema is very powerful. Do check it out if you haven't already. Yeah. So you can go and create an alert, and in the alerting section here. And once you're done with that, you can check the alert and try to do a preview as well. So as you can see here, currently is more than 2 hours, like my current value is false and the threshold is true. As soon as the threshold is reached, we'll get instant notifications and then we'll respond accordingly.
All right, well, thank you all for your time.
Thank you so much.
We'll see you around the venue.
Yeah.